We are going to start off with 6.3 here, and it's a fairly challenging identity. And what makes it challenging is that it's sometimes hard to see what's going on. But I'm going to start this off, and some of you will ease through this. Me, myself, I've had to try it 2 or 3 times to get it going. So I'm just going to say left-hand side is equal to cotan x minus cosecant x. And my right-hand side is going to be equal to cosine 2x minus cos x divided by sine 2x plus the sine of x. So I have the left-hand side and the right-hand side, and I'm going to manipulate these. So the left-hand side is equal to the cosine x over the sine of x. That is the definition of cotangent. Also, the definition of cosecant is 1 over sine of x. Now, I notice that they have common denominators, so I can just combine these fractions by having cos x minus 1 divided by sine x. Now, that looks pretty clean and simple. So I think that this is my target that I'm going to try to get the right-hand side. Admittedly, the right-hand side looks a little bit more robust. So I'm going to take a look at my identity sheet, and maybe, just maybe, I'm going to try to figure something out. And when I do, I have double angle identities, which should pop out at us, right? Because I have cosine 2x. And whenever we're solving trigonometric identities, we likely should always try to get it as a single angle identity. So if I notice cosine 2 alpha, the double angle identities for cosine, there's actually 3 of them. Now that's not very agreeable to me. So instead, I'm going to use some thought here and maybe some trial and error. Now, good fortune shines on those who practice the most. So I think that I'm just going to plug in sine 2 alpha into my double angle identity in the denominator, and then I'm going to revisit this. So sine 2x is equal to 2 sine x cos x for my double angle identity. So I'm going to use this one for sure. It's the only option. Now, don't forget, now I almost forgot to add sine x, because sine x was that term there. So if we keep in mind that on my left-hand side, my denominator is just sine x. Now, that's kind of curious. And what do I notice about my denominator is that both terms have the factor sine x. So that's good. So I would like to cancel out everything that's not sine x. And how do we do that? Typically, we're going to have to factor. Now, I'm going to revisit what we're going to be doing, but I'm going to challenge us ahead, right? So which one would I use? Now, keep in mind on the left-hand side, it's cosine minus 1. And if I notice this one has cosine and sine. So if I plug in my first double angle identity for cosine, it's going to have cosine squared and minus sine squared. I actually don't think that's the one I'm going to use. The second double angle identity is I have sine squared. So if I substitute cosine 2x with 1 minus 2 sine squared x, I don't think that's going to get me farther ahead. However, I think this one is going to be a candidate simply because it only has cosine and 1 in there. So I'm just thinking, what could possibly happen? Maybe I have an expression with just cosine in the numerator. I'm going to give this a shot. So instead of cosine 2x, I'm going to write 2 cosine squared x minus 1 and I have to subtract my original term of cosine x. So I'm just going to simplify things if you don't mind. I'm going to reorganize it. So I'm going to have 2 cosine squared x minus cosine x minus 1, all of that divided by 2 sine x cos x plus sine x. Now, you may think that I'm actually fairly far away from this. Now, keep in mind what my left-hand side said. I'm trying to get my left-hand side to be cosine x minus 1 divided by sine x. Wouldn't it be nice if we could factor out a constant term from the denominator? Let me do that. If I notice, in the denominator, I have a constant term of sine x. And when I do that, I end up with 2, so sine x times 2 cos x plus 1. Now, in the numerator, I can also factor out this quadratic trigonometric expression. So I'm going to say, I'm going to factor the top, and that factors into 2 cos x. All right, let's try to factor that. And wouldn't it be nice if it just factored so nicely? So, in fact, I believe it's 2 cosine x plus 1 minus 1. Or 2 cosine x plus 1, close brackets, open brackets, x minus, or cosine x minus 1. The way that I've written. And I don't think I've made a mistake. Now, what do we notice? We notice that there's a common factor of 2 cos x plus 1 in the numerator and the denominator. So, in fact, what I get is, once I cross out those factors, I get cosine x minus 1 over sine x. So, what do I have? I have my right-hand side is equal to cos x minus 1. I have my left-hand side is equal to cos x minus 1 over sine x. So, really, what I can say, therefore, left-hand side is equal to right-hand side. Thus, the above is an identity. And since I'm done my proof, I'm going to put my little square. Done as dinner.